Okay, so we are going to discuss the June 2020, the October 2020 paper. We'll start with the first question, first read. The discrete random variable x takes the values -1, 2, 3, 4, and 7 only. Okay, so they have that saying here is a discrete random variable, right? So which means your x values are only supposed to take these values. And given that the probability of x equals, so they have given you how to calculate the probability. So what do you do here, children? Obviously, make a table. Write the x values, and using the x values in this equation, you can calculate the probability. Okay, so let's make the x values and the probability table. So x value, probability, the x values are -1, 2, 3, 4, 7. So make a table and probability capital X equals simple x. So what do you have here? So can you all calculate the values? All you have to do is put the x values into the equation and find. So do it. Okay, so what do we have here? So when x is -100, children replace the x here with -1, 8 minus -1. 8 minus -1, what do we have? 8 minus -1 divided by k, which gives you 9 over k, right? When you replace x with -1, 8 minus -1. So 8 minus -1, that's 9 over k. Okay, children, so this is 9 over k. And then the next one, x is 2. So 8 minus 2, children? Yeah, 8 minus 2, that's 6 over k. Then when 8 minus 3, 5 over k. 8 minus 4, 4 over k. 8 minus 7, 1 over k. Okay, right? -1, 2, 3, 4, 7. Okay, now how do we first get the k value? How do we get the k value? What do we know in a probability distribution about the probabilities? Total probability equals 1. So add everything. 9 over k plus 6 over k plus 5 over k plus 4 over k plus 1 over k. All of this must add up to 1. Total probability must be equal to 1. So add everything. The denominator is common, right? K is a common denominator, which means you can directly apply at the numerator. So k is a common denominator. Add the numerator, children. 9 plus 6 plus 5 plus 4 plus 1. How much is it? Add 9, 6, 5, 4, 1.
25.
25. So 25 over k equals 1. And then the k will go to the other side as a multiplication, isn't it? So k equals
K equals 25.
K equals 25. So that's not what we need. We need to find the value of ex. So let's get ex. So to get ex, you must get the x value along with its probability. So -1 times 9 over k plus 2 times 6 over k plus 3 times 5 over k plus 4 times 4 over k plus 7 times 1 over k. When you all add everything here, k value is 25. Actually, we can put it at the end.
Constant.
K is a common denominator, right? Because again, k is common to everyone.
Everyone.
So you can type in your cal -1 times 9 plus 2 times 6. I mean, you can simply give like that in your cal. You can type in your cal
9 plus
like this, yeah.
2 into 6 plus
5.
3 into 5
2 times 4
plus
1 times 1, that is 7. And that gives you 41. Am I correct? 41 over k.
Yes.
And
yes,
k
41.
value is actually directly
25.
So k is 25. So 41 over 25.
25.
Your EX.
1.64.
Yeah.
1 over 25. Yeah, 1.64.
Teacher, do we need to keep the decimal
You
place?
can keep either. You can keep either. Okay, so you have to keep either exactly 1.64 without doing any more rounding. Directly 1.64.
Teacher, may if there's like a continuous decimal, we better keep it in the
Fraction. Unless they ask you to keep it in 3SF, or if they ask you here, they haven't. So it's fine because both of them are exact. So that is
yeah.
Okay. So question number 2. In a school canteen, students can choose from a main course of meat, fish, or vegetarian. They can choose a drink of either water or juice. The partially completed T diagrams where P and Q are probabilities shows the probabilities of these choices for a randomly selected student. complete the tree diagram, giving your answers in terms of P and Q where appropriate. Right. So now you can see in this tree diagram. Let's consider the first branch. So when you consider the first section of your tree diagram, I'm sorry, the first section has how many branches? The first section has 3 branches. So the
Yeah.
rule in the tree diagram is what, children? The total probability of all the branches must add up to 1.
1.
So 0.40 means 0.35 fish, which means how much should it be for
0.25.
0.25? How do you get 0.25? By
Add
subtracting these two guys from 1. 0.4
then minus, yeah.
0.35, you subtract it from 1. Okay. Then they're asking you to complete, you have to complete the tree diagram, giving you answers in terms of P and Q. So over here. So over here in this section, you can see there are two parts. So in here, these two add up to 1, which means if the top branch is P, the bottom one should be the
1 minus P.
the total probability must add up to 1, isn't it, children? The total probability, so if this is P,
Yes.
total probability of these two must be 1. This must be 1 minus P. Okay?
Yeah.
This must be 1 minus P. Similarly, in the other one,
1 minus Q.
1 minus Q.
this is 0.4. means
Yeah, 0.4. So yeah, that 1 minus 0.4. 1 minus
0.4, which is 0.6. Okay, children?
yeah.
So 2 marks are, that's quite easy. Next one, find an expression in terms of P and Q. The probability that a randomly selected student chooses water to drink. Okay, so you need to find, they ask you to get the answer in terms of P and Q, okay? So the probability of selecting water. Children, select all the parts. Can you select all the parts that end with water?
0.040 into P. No. And then you have 0.035 into Q.
And 0.2.
0.025 into 0.0.
Yeah, extra 0.25. Don't say extra zeros. Be careful. Okay.
Did I?
Yeah, you said extra 0. Okay.
Okay.
0.40 into P. Okay. So that is the first part. You know, along the path, probabilities are multiplied, and then the different parts you must add the probability. So plus the second part is
0.35 into Q
and then the third
plus 0.25 into 0.4.
You don't have to color your tree diagram, okay? Please don't color your tree diagram. I just colored it to, highlight it to you all. So do not go do anything like that in the exam, okay? So I'll erase it. Okay, let me erase it. Just because, I have
Yeah, they say highlighters are banned. Probably it or something.
you can't do anything like that. Don't destroy the diagram. Okay, I just highlighted to show it to you. So how much is the answer? Can you kind of simplify it for me? 0.4p plus 0.35 q, and how much is the one? 0.25 into 0.4? 0.1. Yes, right? Yeah. So I have the answer on the chat.
Yeah.
Okay, then let's go to part C. Okay, then part C. This is part B, right? Okay, part C. The events choosing a vegetarian main course and choosing water to drink are independent. Find a linear equation in terms of P and Q. Children, you need to remember this story. What is the independent story? What is the independent story? If two events are independent, if two events A and B are independent, then probability of A intersection B equals to probability A times probability of
probability
B.
B.
Two events are independent. So now, what are the two independent events? They say choosing a vegetarian main course. So let's say vegetarian is B, and they have given vegetarian is B and water to drink. So these two events, vegetarian and water, they are independent. So that means what? Probability B intersection W, like A intersection B. B and W are the two independent events. So V intersection W equal what? Probability V times probability W. Are you guys okay with that?
Yeah.
So let's take the answers for that. So they are asking you to get a linear equation in terms of P and Q. Okay. So V and W, do we have a path or anything in the tree diagram? Check where you have vegetarian and water. Vegetarian,
Third one.
vegetarian and water. Do you see such a path?
Yeah.
Yes. Can you see vegetarian and water. What's the probability of that part?
0.25 into 0.4.
0.25 into 0.4, right? 0.25 into 0.4 is getting being vegetarian and taking water. Okay, so next one, equal probability of vegetarian. Children, what's the probability of vegetarian? The probability that you are choosing vegetarian?
0.25.
0.25. Probability of choosing vegetarian is 0.25 into probability of water. Probability of water, you don't have to sweat because why? We have found that in part B, the choosing water in part B. So that answer is found, children. So substitute that. How much is it? 0.4p, 0.35q plus 0.1. So they ask. So this is it, children. All you have to do is now kind of simplify it and make it into a linear equation. Is that okay? Are you guys with me? 0.25 into
Yeah.
0.25 into 0.4 is 0.1, right? And can you all open the bracket? Or else, you know what, shall we take the 0.25 to the other side as a multiplication, the division?
0.25.
I think it's easier, right? Then this side becomes free. The decimals are also easy.
205. 0.4.
0.25 is
205.
2 over 5.
Yeah. Natang danu bulan 0.4 kira.
We put 0.4. Yeah. Take the 0.1, subtract 0.4 minus 0.5 is
0.3. That is, yeah, okay, it's minus.
Then what we'll do is we shall be, I want to get a linear equation, like a nice equation. We can keep it like this, or you know, we could simplify it a little bit more. How many marks? Just 2 marks, right?
Yeah.
Leave it like this actually. Isn't it? If you want, you can multiply by 10, but I think this is enough linear equation. So this should be good enough. Just 2 marks. You could simplify more by multiplying by 10, removing decimals, trying to give everything in what? In integers. You could always just leave it like this because I think our time is more important. Next one. A student who has chosen juice to drink is selected at random. Okay, so juice is the other option, right? The probability that they choose fish for their main course is 7 over 30. Find the value of P and Q. Okay. So children, now in here, this question, you need to be very, very careful. Why is that? They are saying a student who has chosen juice to drink is selected at random. Can you see? So are we having, we are taking a student who has chosen juice. The probability that they means what? That the student who chose juice. So now it means that now our probability, are we considering the entire student body?
No, it's conditional probability.
Yeah, we are now not considering the entire student body. We are only considering the people who chose juice, which means what? This is conditional probability because we are only taking a section of our graph. We are not considering the whole body. We are only considering the people who have chosen juice. Definitely, it's conditional probability, and automatically the given that is what? The given that should be the people who has chosen juice because your entire body is made. You take the full body to be the people who chose juice. Out of that only we are taking the probability now. Okay, so the people who chose juice to drink, that is the given that. Okay, and so the probability that they chose fish. Understood? For the main course is 7 over 30. So how do we write this nicely? So probability, it's a given that. Okay, so probability of choosing fish, given that they have given that they have chosen juice. So we take it from the juice population. The people who have chosen juice, out of them, how many have taken fish? So when we open this, this is probability fish intersection juice over probability of juice, right? Do you agree? This is
Yeah.
conditional probability, right? Efficient.
Yeah.
So probability of fish and juice. So what is that probability? Fish and juice. I think you can see it, right? Can you see? Fish and juice. So 0.35 fish, and then choosing juice is 1 minus Q. Can you all understand?
Yes.
0.35 into choosing juice is 1 minus Q. over probability of juice. Okay. How do we take the probability of juice? Children, how do we take the probability of juice? What do you think? Juice is there in how many parts?
Juice is there 1, 2, 3.
Then juice,
3 parts.
juice. Now you can see, if you want, you can go along all the 3 parts and write all the 3 people. Or children, you have another option. What equation? What is the previous one? What is the other option?
Wait. We found water, right?
But what is it that you said?
We found water. We can minus it.
We can minus that from what to that?
The total.
The total
One?
probability is 1 always.
Yeah.
Drinks, you only have 2 choices. So either you are drinking water or you are drinking juice. Definitely one of the two. So since you found the probability of water, the juice probability is 1 minus that. So that is one way. Or the other way is, of course, you go along all the 3 parts and get it.
Time consuming.
Time consuming. Exactly. So probability of juice is 1 minus the probability of water. Definitely. Okay, because juice and water are your 2 options. So the given that probability is given, right? The fruit, they have set the probability that they choose fish. So this given that probability is 7 over 30 children. Can you see it's 7 over 30? This probability, given that probability is given to it. They have mentioned it 7 over 30. So now put it there, and then you have to kind of like make another equation what? With P and Q. End of the day, that P and Q equation should be solved with this, and then we get the PQ value. That's why it's 5 marks. Okay, happy solving. Now let's solve. 7 over 30. 7 over 30 equals 0.35 times 1 minus Q. Okay, this needs a lot of patience. 1 minus, so better to put it inside brackets, right? Probability of water. What was the probability of water? But they have not given us anything. Didn't miss anything. Okay, probability of water 0.4p, 0.35q. Plus 0.1. I'm just copy pasting the answer from part A. 0.4p, 0.35q plus 0.1. Okay, so I get here 7 over 30 equal 0.35 times 1 minus q. I think I can subtract 1. This is minus 0.4p minus 0.35q. 1 minus 0.5. Directly, shall I write? 1 minus 0.1 is 0.9, right? And these two guys will be negative, minus 0.4p and minus 0.35q. Is that okay? And then it's time to kind of like cross multiply. I'll take 7 with this guy and 30 with this guy. Is that okay? And shall we directly multiply without wasting steps? 7 times 0.9, 6.3. 7 times 0.4, 2.8p. 7 times 0.35, 2.45 q equals, then the 30 goes and multiplies with the 0.35. 30 times 0.35, how much? 30 times 0.35, 10.5. 10.5 bracket 1 minus 2. I didn't open that bracket yet. So 6.3 minus 2.8. We check the value, children. 2.45 q. Open the bracket here, I get 10.5 minus 10.5 q. So let me take the p's and q's to one side. Actually, what I'll do is I'll take the 6.3 there. And I'll take the 10.5 here. Is that okay? Minus 2.8q minus 2.45q plus 10.5q equal 10.5 minus 6.3. Can I know the value here? How many q's are there? Minus 2.45 plus 10.5. How many q's are there? Minus 2.45 plus 10.5.
8.05.
8.05 cube. So the 10.5 minus 6.3.
4.2.
4.2. So this is the second equation. Can you see? So now they are asking you to get the values of P and Q, right? So this equation along with the earlier equation. You have to solve these two guys simultaneously. Okay. Oh, okay. What you could do is you could make one person the subject and put the other anything. Okay. So I'm not gonna simplify and make it into integers because I feel it's a waste of time. What I'll do is I'll just make 3 the subject here and put it to the other equation. Shall I do like that? The first equation is 0.3 equal 0.4p. Can you all tell me the first equation? The first equation is 0.3 equal, what was it?
Equals 0.4p plus
0.3 equal, right? 0.3 equal 0.4p plus 0.35 give away. So let's substitute, children. Or else I could multiply the first equation actually by 7, isn't it? To get 2.8, 7 times 4, 28. Shall I do like that? I think it will be easier than multiplying. I'll multiply by 7. Because if I multiply it by 7, I get here 2.8p. Can I have 7 times 0.35? 7 times 0.35? 2.45 cube. And 0.3 times 7, 2.1. So now I think these two equations are looking good. So we can add them. So when you add them, do you see what happens? 2.8p, 2.8p cancels. 2.8p, 2.8p cancels. And what do you get here? Plus 2.8p will cancel. And then what happens to the Q values? Can you all add? 8.05 Q,
10.5.
10.5 Q. At the 4.2 and 2.1, when you're adding 4.2 to
6.3.
6.3, right?
3. Yeah.
Then Q is how much, Buddha? 6.3 divided by 10.5.
0.6.
0.6. Okay, so you can do this in many ways. Now, this I feel it's a little bit messy and kind of looks like a little bit dangerous because you're dealing with so many decimals. Okay, so if you all really wanted, you could have made it fractions and multiplied the entire thing by that figure to make it all integers. It looks a lot more neater then, actually. So this is what came to me now, but it depends on the exam. If you all want to, when you see the decimals, you could immediately with the cal you get the fraction. You look at the fraction figure, multiply the whole equation by that number, by a number to make it all integers, and then it looks a lot easier. So anyway, up to you all. So this is the way I did. I mean, anyway, like any other way is also correct. Okay, there is no one correct way to simplify. Okay, and then what's the p-value? Substitute, children, what's the p-value? I'll put the 0.4p plus 0.35q equals 0.3.4p. 0.4p, 0.35 times q is 0.6 equals 0.3. 0.4p equals 0.3 minus 0.35 times 0.6. Then p equal that whole thing divided by 0.4, right? How much is the answer?
0.225. P.
The final answer for p, right? After you divide by 0.225.
225.
0.225. Is that okay, children? The others? Talk with me and let me know
Yes,
if you
teacher.
have any issues. Okay? Solving simultaneous, I'm telling you once again, this is not the only way. You may go in a completely different path. That's perfectly fine. But you must end up getting the answers. Now, these are the correct answers. So you have to end up getting PQ answers in this manner. If the answers are different, then that's a problem. Okay, so that's 5 marks. That's done. The canteen manager claims that students who choose water to drink are most likely to choose a fish main course. State showing your working theory whether or not the manager's claim is correct. Okay. Now, what's the manager's claim? He says that the fish manager claims that students who choose water to drink, okay, are most likely to choose a fish main course. State showing your working theory whether or not the manager's claim is correct. Okay, so what we'll do here is, children, what students are we concerned here about? What students are we concerned here about? The students who choose what?
Fish.
No.
Water.
Now the candidate manager claims the students who choose water. Now he's analyzing the students who drink water, and he says the students who drink water are more likely to choose fish. So are we considering the entire student population now? Are we considering the entire student
Only water.
population?
Who drink water only?
We are only considering the people
Only water.
drinking water. So once again, what probability?
Conditional.
Conditional. Once again, conditional. Why? You are not considering your entire population. Remember, the moment you select only a part of your population to do a sum, it's conditional. So you are only taking the people who are drinking water. So out of that, so remember immediately it's conditional. So what is the manager saying? Out of the people who drink water, he says they are most likely to choose fish. And look at this. So here fish given water. So he says this probability is the highest. So how do you claim? How do you say whether what he's saying is true or not? You check the other option. What are the other options that a student has who drinks water? They can choose from students who drink water. They can eat either meat and water, right? You have that option, or you can have vegetarian
And water.
So the students who drink water, these are the options they have. So out of the students, now he says, out of the students who drink water, many are likely to choose fish. So if many are likely to choose fish, what does he mean? He means that this fish given water probability is the highest. Probability is how much it occurs, right? So the higher probability means it's occurring more. So what he's saying is out of these three probabilities, he says that this is the highest. So you have to say whether it's correct or not. So how do you say whether it's correct or not? You have to calculate all three and see whether this value is the highest of all the three. Understood? So check whether this value is the highest, children. Do it. So check whether that is the highest. What is the answer here? Fish given water, probability fish intersection water over probability of water. I think better that we get the probability of water and all this stuff, right? Because PQ values are not found. Okay, so what's the probability of water? That should be found first. Probability of water was in part A, what was it? 0.4p, 0.35q plus 0.1. So I'll get the probability of water, 0.4p, 0.35q plus 0.1. Put the Q values, P value we found 0.225, Q value is 0.6. Please put those two values. How much is this? What's the probability of drinking water?
0.4.
0.4. Okay, so the probability of drinking water is 0.4. Okay, so then what do we have here? A fish given water. Okay, so fish given water, get the probability. So multiply fish is 0.35, Q value you found as 0.6, right? So you can mark it on the diagram itself and find fish and water. Multiply and get it on here. 0.35 into 0.6. Multiply fish and water. 0.35 into 0.6, right? 0.35 is 0.21. So fish and water. Meat and water, that also multiply. P value is 0.225. So multiply meat and water. 0.40 into 0.225. How much is it? 0.40 into 0.225.
0.09.
0.09.
Yeah.
The next one, vegetarian and water. Actually, vegetarian water, they said it's independent also. Anyway, we'll multiply and take. How much is it? Can I quickly tell? 0.25 into 0.4. Actually,
0.1.
so we get the values here. You could fish intersection water 0.09 divided by 0.4. Get the answer. Meat
0.525.
Sorry, fish and water, I made a mistake. Fish and water is 0.21.
Yeah.
Fish and water is 0.21. Meat and water 0.09. This curve is of course independent. If vegetable and water, vegetarian and water are independent, which means this is directly equal to probability of vegetarian. There is a rule like that. If two events A and B are independent, then A given B is equal to probability of A. If A and B are independent. Okay, so anyway, you can either use that rule here. So we are vegetarian and water are independent. So you could say directly this is probability of vegetarian. Or else, okay, anything is fine. So we can get the value here. It will come anyway. So this is 0.1 over 0.4. How much is it? Get me the three answers. The first one, 0.525, okay. 0.225, this one. 0.25 is equal to probability of vegetarian, right? You see, vegetarian given water is equal to, okay. So now, manager's claim is correct or not? The manager says that the students who drink, some students who drink water, they are most likely to choose a fish main course. Is the manager's claim correct, children? What do you think? Yes, Nick? So you can see it's more than half. The probability is more than half. It's the large. I mean, you don't even need to calculate. You know, the moment you get this value more than half, the other two values you don't even need to calculate. Why? Because the total probability is 1, children. Out of total probability 1, when this value itself is more than half, can the other two values ever exceed? No, you don't actually even need to find these two. So actually, if you think like that, these two values don't need to be found. Why this value? Because these three add up to give you 1. So when these three add up to give you 1, this itself is more than half of the probabilities. Understood? So anyway, I have calculated all the three here. It's just getting 1 itself is also enough, children. Okay, so you can write here. So you can write the probability of fish given water, probability of, or you can say, better write like this, right? Probability fish given water is the largest. Is the largest. So manager's claim is correct. So if you are a person who didn't find the other two, you could say the given water is 0.525, which is bigger than 0.5. Therefore, definitely, therefore, this value is the largest, and the manager's claim is correct. So you can even do that without finding it down to probabilities. IAL, okay, children. So this is I think the last part was a tricky one. The other questions were not that much bad. The last question was a little bit of a tricky one. Okay. Okay, so question number 3. The distance achieved in a long jump competition by students at a school is normally distributed with mean 3.8 meter and standard deviation 0.9 meters. So distance, X is the distance. So distance achieved in a long jump competition. The distance that you jump. So X follows a normal distribution. Okay, so X follows a normal distribution with what? With mean distance is 3.8 meters, standard deviation 0.9. Remember, you are writing, when you are writing the distribution, this is variance. So 3.8 comma 0.9 square. Okay, because you are writing the variance when you are describing, when you are introducing your distribution here. Students who achieve a distance greater than 4.3 meter receives a medal. Can you guys understand this? So this is the normal distribution. You don't need all these extra things. The mean distance is 3.8. Okay. So students who jump a distance greater than 4.3. So 4.3 is somewhere over here, right? Greater than 3.8. So the students who are in this region. The students who fall to this region, they receive a medal. Find the proportion of students who receive a medal. So what probability do you need to find, children? Probability that exceeds the distance jump should be what? Greater than
4.3.
4.3. This is to receive a medal. So then let's get the value probability. The x becomes z when you turn standard normal. How you turn standard normal? The x value, you subtract the distance, you should subtract from the mean distance and divide by the standard deviation. How much is this in the calc? 4.3 minus 3.8 divided by 0.9. How much is it?
0.555 recurring.
0.555 recurring.
Yeah.
So actually, you know what happens here? When your table has only 2 dp. So correct it to 2 dp. What's the correction to be 2 dp? 0.56.
0.56.
Okay. So now what you can do is you can use your tables, or you could use your calculator to get the same answer as the table. If you get the 2 dp value in the calc, you get the same answer as the table. So your mode should be the stat mode. Number 3, stat mode. Don't select any of these options. Okay, then you go shift and 1 and you go to the options in the stat mode, and number 5, distribution. And then we go with number 1. Normally number 1 P is giving you the area which way? Number 1 option gives you the area in
Below.
front. It gives you the area behind the line. Remember, number 1 option gives you the area behind. There are other options here actually. Number 3 option actually gives you the area in front of the line, children. So if in an event you forget, Shah can clearly put it inside your head. P gives the area behind the line, R gives the area in front of the line. Otherwise, what you could do is you can stick with one person, get the area behind and subtract from 1. So anything you prefer. Okay.
Yeah.
So I'll go with which one? Shall I directly go with the area in front, or shall I use P? Which one do you prefer? No preference. If I go with
Can
number
you use
1,
R,
Let's
right?
let's go.
number 1 P, then P is this. I have to get this answer and subtract it from 1. 1 minus the P answer. Okay. 1 minus, because P gives me the area behind and I don't want the behind area, I want the in front area. Subtracting 1 from 1 and you can give your answer to 4 dB, you get the same as the table. 0.2877. Table answers are to 4 decimals. So you make sure this is also 4 dB, 0.2877. So you get the same answer as you would get in the table. Okay. Okay, then the next one, part B. The school wishes to give a certificate of achievement or a medal to the 80% of students who achieve a distance of at least 3 meters. Can you see? The school wishes to give a certificate of achievement or a medal to the 80% of students who achieve a distance of at least 3 meters. Find the value of D. Can you look at this normal distribution and tell me what 80% are they referring to? The 80% now you know, this is an achievement, right? The certificate of achievement for students who achieve a distance of at least 3 meters. And that is for the 80%. So actually, the 80% of the lowest performing students or the 80% of the best performing students? The 80% of the best performing students are only getting the certificate of achievement and the medal. Okay, all the medal, not and all the medal. So where do we take the 80%? Should I take the 80% from the beginning and take 80%? Or the other way? From this side, right?
Yeah.
You know, because you know at the very beginning you have the people who are jumping like a very low value, right? So at the beginning you have people who jump a very small amount. So at the very end you have the people who are having some kind of an achievement in jumping. So 80% of the best people. So 80% best people you should consider from this point 80%. So you know the distribution covers 50% until 3.8. So 80% is another 30% over here, right? Shall I draw the diagram? Part D, right? So draw the normal distribution.
Agreed. Let's go.
Okay, so how do you draw the normal distribution? Now I'll draw the same normal distribution. Mean is 3.8. So they are giving the medal to the 80% best, not medal, the certificate. So the certificate for the 80% of the best students. So 80% best students you take from this corner. Understood? From this corner, I think it goes somewhere like over here, right? somewhere like over here. So the 80%, the best 80% of the students. You guys agree? So this is the best 80%. So out of that best 80%, the corner people are the ones who get the medal, the very corner. The others get the certificate. Because this is certificate or medal. That means you need to realize the medal students are also coming there. And in addition, the people who are over in this region, the middle region, are getting the certificate. So then that distance is B, it seems. That distance. Okay, the school which is to give a certificate of achievement. So the 80% of the students who achieve a distance of D meters, at least D. Okay, so find the value of D. What is the area behind here? Behind D? I think this area is 80%. The behind area is 20%. I think it's easier to work with what? The 20%. You know why? Now you know normal distribution has two tables. Okay, so you can see these probability values are like good probability values, right? There are two tables. One for the kind of like the messy probability values. The other one a good table with the good probability values. So 0.2 is actually there in that table. Do you remember? 0.2, 0.15, 0.025 such probabilities are there in the second table, children. Okay, so let's first write the thing we need to find. So part B, I want to find the probability that X is what? What will I choose? Now it's entirely up to you to choose the way you write this. X greater than or whether X is less than. So what is the most easiest one to do here? Should I go with X greater than D or X lower than? You go with X less than. You can go X greater than, children, right? X greater than D is 80%. But that's complicated. It's easy to, I mean, there's no problem. But we can go with X less than D and say this is equal to 20%, 0.2. Understood? And this, so they are directly, you can turn this to standard normal, X becomes D, and D you convert, right? D minus the mean is, you convert this to standard normal. So D minus how much is the mean? Mean is 3.8. I have it here. Mean 3.8 divided by standard deviation is 0.9, right? And then this value, of course, you could say this is what? Q. Q. So definitely, this D only, actually, this D is the person who becomes Q in the standard normal graph. Are you with me? The 3.8 becomes what in the standard normal? The mean of the standard normal graph is 0. Can you all remember? The standard normal graph mean is 0. 3.8 becomes 0. The D is the one that becomes Q here. So definitely, what do you understand? This is a positive. Q is a positive figure or a negative figure? Q is a positive figure or a negative figure when it's behind 0. It's behind 0. Q should be negative. Understood? So now take the normal distribution of the first table. Take the second table, not this one. Okay, not this one. Take the second table. Okay, take the second table. This one. And in this table, children, you all remember they are giving you the probability values for the area in front, right? This is the table and they give you this probability and the Z value. The probability. So the probability is given first and the Z value. Now what was our probability value? So in our case, the probability was behind. Okay, this side. But this table doesn't give the other side, but we can use the what property? The table is normal distribution is for symmetry. Okay, so if this area, the area we want is 20%, isn't it? 0.2. So you can think of it on the other side. 20%. So 20% area, 0.2 area, probability, what's the Z value? 0.8416 is the value here. But in our case, the 0.8416 is on the other side because our area is on the other side, which means this value is what? Negative
minus
0.8416. Do you guys agree? The value that we want is a negative figure. We use the symmetric property of the graph. Okay? So the Q value, I think we mark this as Q, right? So Q value is negative 0.8416. Understood? I'm going to clear everything here. Okay, negative 0.8416. So mark it. So Q value is equal to negative 0.8416. Who is Q now? Q is D minus 3.8 over 0.9. That's what we use for Q, right? Equals negative 0.8416. Are you guys with me? This is what we use for Q. So replace the Negative 0.8416 multiplied by 0.9 plus 3.8. How much is
3.04256. 04256.
3.04256.
256. Yeah.
They don't have any significance for the D value. They haven't, right? So we'll give it to 3SF 3.04. Something like that. 3.04 meters, right? We are measuring this in meters. Okay, children. Shall I go to the next part? You guys are clear with this, right? Then the next one, of those who received medals. Okay, so once again, be careful now. Okay, they are again talking about the people who received medals. Children, who are the people who received medals? The people who received medals are the people who jumped more than 4.3 meters, right? The people who jumped more than 4.3 meters, that is this 0.2877 or 28.77%. So this 28.77% here, this percentage is the one who received medals. So of those who received medals, so be careful, children. The 1/3 who jumped the furthest will receive gold medals. Okay, so now children again, what do you see here? What do you
Condition.
see? Are we taking the entire population or of those who received medals? Only that those who received medals is only the people who jumped more than 4.3. So we are going to take only that small portion. From that portion, the 1/3 who jumped the furthest. Can you all see, children? So this is definitely what probability? Definitely conditional probability, because we are only taking a section of our graph. We are only taking a part of our population. We are not taking the whole thing. Are you with me? So I am taking only a part of the population. Okay, so here is this population. So this more than 4.3, right? So these are the people who receive medals. Let me draw it here. So this population is the one who receives medal. Now we are only interested in this population. Are you with me? This is the population who receives the medals. Okay, so this is the population who receives medals. So out of those people, so we don't need this section. Okay, you can remove it. Okay, so remember this section is not needed. We don't need it. So this, so that means automatically you know your total probability is what? Definitely you know in your conditional probability the total probability what is 0.2877. It's like your denominator is 0.2877 because you know you are taking the probability from this section. Are you with me? Okay, so what are they saying here? So anyway, they are saying here the 1/3 who jumped the furthest. The 1/3 who jumped the furthest means what do we do here? The medal population you divide into 3 sections. The medal population is divided into 3 sections, and we take the people who jump the furthest means we have is it at this beginning or at the very corner? The furthest,
Corner.
at the very corner, the far edge. Okay, so we take 1/3. So let's say this value is over here. Okay, so gold medal, shall I put G here for gold medal? So this population is receiving. So the people who receive gold medals, like 1/3 of the medal area. Do you agree? 1/3 of the area of the medals. I mean, you have this full area 0.2877 is the yellow color area. So 1/3 of that area, I mean, we divide the medal area, I mean, we take 1/3 of the medal area, the furthest corner for the people who take gold medals. Can you see? So this red color area is the people who take the gold medals. Great. So it's 1/3 of your yellow color area. Understood? So find the value, so find the shortest distance G that must be achieved to receive a gold medal. Children, so what is this area? So what is this red color area? The probability of getting a gold medal. What's the probability of getting a gold medal? Can't you immediately say it? 1/3 of that the yellow color area, isn't it? It's 1/3 of the yellow color area. Are you guys with me? Okay, so probability of getting a gold medal. I think we can directly write here because we are trying to find the distance to achieve a gold medal. So probability of getting a gold medal. Okay, probability of getting a gold medal is 1/3 of the medal area. Isn't it? 1/3 of the medal area, but that should be divided by what? It's
28.
yeah, that's 0.2877 because you are not taking the full population. We are only taking that section of the population. How much is the answer? 1/3 of 0.2877 divided by 0.
1/3.
It's 1/3, right? So it's just
Yeah.
1/3. It's just 1/3. So probability of winning a gold is 1/3. Okay, so they want you to find the distance. So probability of winning a goal. So probability of winning a goal, the distance, the x should be what? Bigger than. So this distance we'll say d or something. I don't know. Gold I use g. This value g. You need to find the value of this g. So probability x greater than g is how much? 1/3. Because you found this area is 1/3. Okay, so get the value of g. Again using standard normal. So x becomes z. This is g minus mean is how much? 3.8 over sigma is 0.9, right? Sigma is 0.9. 1/3 is 0.3333. So this is not a good probability, right? This is a good probability. So this is let's say this is a PQR. Let's say R. Can we use the first table? Can we use the second table? And the one with the good probability? No, we have used the first table. The first table. Okay, so definitely, so you can see the value here, and this R, this G is what becomes R. Can you see? This G is what becomes R. So R is definitely a positive figure or a negative figure. When it becomes standard normal, you can see it's in front of the zero. It's positive because the standard normal, this value becomes 0. So R is definitely positive. Okay, take the graph, and however, there's a problem, right? In our first table, does it give you the area in front? No, it gives the area behind. So can you all take me the area behind? So this area greater than R is 0.3333. So behind area is 1 minus 0.31 or 1 minus 1/3, which is 2/3, right? 2/3 is 0.6667. 0.6666. So we have take 6667, right? Correct 4 dB. Are you guys with me? Because the table, why am I taking behind? The table gives you the probabilities behind, not the probabilities in front. So here, children, the probability and the z columns are flipped. Okay, you all know the way to read this. The probability and the z columns, they are flipped. So what you have here, 0.6667. Search what's the closest figure. 0.6667. The probability figure is the second one. The z value is given first. 0.6667. What's the closest figure? I think the closest is 0.6664, right? Am I correct?
Yeah, 0.43.
Okay, am I taking it correctly? Okay, so children, there is a small thing to correct here. Okay, so actually the probability that I found here, so actually I should not go over here. There's a mistake. Okay, so the mistake here is children, the probability that we found here, this is a conditional probability, right? So we found the probability of getting a gold medal given that. What is the given that here? I did not write the given that here. Probability of getting a gold medal given that you have a medal. The probability of getting a medal, a gold medal, given that you win a medal. This is 1/3. Okay, so this is the conditional probability. Actually, this 1/3 is the conditional probability. So using the conditional probability to get the distance is not going to help you, children. If you want to get the G value here, if you want to get the distance that you need to achieve to get the gold medal, you need to find the real probability, like out of the total area. Because here this conditional probability is this 1/3 is it out of the entire section? No, it's only from the section where you got. So out of the people who receive medals, 1/3 is the probability that you receive a gold medal. Yeah. So that is that for that you only consider this section. But when we are finding probabilities by using our normal distribution, you can't use a section. I mean the normal distribution area, they consider the whole graph. Okay, they consider the whole graph. I can't take a small section of the graph and especially taking a conditional probability. I can't take a conditional probability. This is a conditional probability that I found. Probability of gold given that you have a medal. So I can't take a conditional probability and actually find it. Okay, so what I need to do is you guys can cut that because that was a mistake. So what you need to do here is the best thing you do is you get immediately. I think this diagram is very clear. The diagram tells you exactly who are the people who win the gold medal. So from the total probability, let's consider the whole graph. If you consider the whole graph, who are the people who get gold medals?
1/3 out of the
1/3.
1/3.
Oh.
Yeah, 1/3 of the people who get the gold medals. 1/3 of the people who get the medals. Yeah, the whole thing is one. So that's fine then. So 1/3 of the people who get the medals is medals area was how much? 0.2877, right? So 1/3 of the medal area. So your medal area is 0.2877. Out of that medal area, now 0.2877 is from the whole area. That area also I divide into 3 and take the very corner. So 1/3 of the medal area, how much is it? How much is 1/3 of the medal area? Give me the answer. 1/3 of the medal area.
Uh, 0.0959.
959.
Yes.
0.0. That's all the decimals you are getting. Or do you get more?
That's exact.
Exactly. 0.0959 is the probability that you are getting a goal. So getting a goal means what? The distance that you are jumping is more than, so that's the distance they are asking, right? The distance G meters to achieve a gold medal, the distance G meters. So that is the distance G, that you have to take it from the entire thing to that. Otherwise, you can't use a normal distribution by using a conditional probability. That was the mistake I did earlier. So X should be greater than G. This probability is definitely 0.095 and considering the area of the entire graph. By considering the entire area of the entire graph, probability of getting a goal is 0.0959. You know, I could have written this at the very beginning. We could have, because we have written it, right? At the very beginning, we had written everything. So we were taking this conditional and, thinking too much about it. Okay, so let's turn it into standard normal. This becomes Z. This is G minus mean is, the mean was how much? Mean was 3.8 and standard deviation is 0.9. So let's write this as what R, right? I wrote it as R. So this G value is what becomes R. Can you all tell me? So the area in front is 0.0959. So we are taking the second table, right? R is at the front. The area in front of R is 0.0959. But you know the second table doesn't give you the area in front, right? It gives you the area at the back. Can you tell me the answer? 1 minus 0.0959. Subtract the area from 1 and get me the area behind. 9041. 0.9041. Are you guys okay with it? 0.9041. So you take the first table. The first table gives you the areas behind. Okay, so can you all remember the first table gives you the area behind the line. That's the difference between the first table and the second table. The second table gave you the area in front of the line. The second table gives you the area behind the line. So what was the area we had? 0.9041, right? So what's the closest we can take to 9041? 9032 is there, 9049 is there. Who is the closest to 9041? 9041 is what you have. What's the closest out of 9032 and 9049? Difference is 8. Here the difference 32 to 41. That's also 9, right? 32 to 42. That's 9.
9, yes.
9049 is closer, right? So we'll take 1.31 then. Take the closest value, children. Take the one whose gap is the closest. So 1.31 is the value who is the closest from the table. Okay. So 1.31. Are you guys okay with it? 1.31.
Yes.
Let me know if you all have to ask anything. 1.31 is the closest value. So your R value is a positive figure, right? It's not negative. R is positive 1.31. So R is G minus 3.8 over 0.9 equal 1.31. So G equal 1.31 times 0.9 plus 3.8. How much is it? This is the distance you need to achieve to get a gold medal. $4.979. Is that okay, children? 4.979. So this is the minimum distance that you need to achieve to receive a gold medal. Agreed? Children, do you agree?
Yes, teacher.
Okay. Then let's go to the next one. Okay. A journalist from a local newspaper interviews a randomly selected group of 3 medal winners. Okay, so interviewing of medal winners. So they are asking, find the probability that there is at least one gold medal winner in the group. Okay, so medal winner, what's the probability? What's the probability of a medal winner? Okay, a journalist from a local newspaper interviews a randomly selected group of 3 medal winners. So medal winner is in this group, the yellow color group. Find the exact probability that there is at least one gold medal winner in the group. So there is at least one gold medal winner in the group. Okay. How do we get that? Gold medal, gold, given that you have a medal. A randomly selected group of 3 medal winners. Okay. So children, they are saying here, find the exact probability there is at least one gold medal winner in the group. Okay. Now the thing here is this. The question here is, are we considering the entire group, taking the full probability of the entire group, or are we only taking a certain section? A journalist from the local newspaper interviews a randomly selected group of 3 medal winners. So that means we are only taking the medal winner category. Are you with me? We are only working with the medal winner category. Okay. So that means we are not, the total probability is not going to be out of 1. It's going to be out of the medal winner, the 0.2877. Okay. So out of the medal winning category, okay, they said he's interviewing 3 people, and out of the 3, at least one person should have a gold medal. Okay. Now, out of the 3, at least one person should have a gold medal. Find the exact probability that there is at least one gold medal winner in this group. Okay, so there is an easy way to do it. I'm just trying to see how to explain it to you all. So this actually you can see now the conditional probability. I think you can see the one I calculated part C. The probability, the conditional probability of winning a gold from the medal category is how much? 1/3, right? So this is, this is the probability from this group, not from the whole section. Because here also they say us to get from the group of the medal winners, not from the whole group. So the probability of winning the conditional probability of getting a gold medal from the medal category is 1/3. Do you agree? Okay, so I want the conditional probability here. I don't want the full thing. So this is conditional probability. The conditional probability of winning a gold medal out of the medal winner category is 1/3. So then not winning a gold from the medal winner category is what? Not winning a gold from the
2
medal
over 3.
category is 2/3, right? Okay, so getting a gold from the medal category is 1/3. So probability of, I'll say G dash, not gold. From the middle categories, 2/3. So remember, this interviewer is only interviewing this pool. Okay? Can you understand? So the pool is the medal winner pool. The medal winner pool has gold medal winners, and the other medal winners are, they don't have gold. Okay, so let's say this event is A. I'll say this event is A. This event is okay. Let's say this event is A dash. Okay, so interviewing a person who from the medal pool who has a gold medal is A. Interviewing a person in the pool of medal winners who doesn't have a gold is A dash, because the probability is also the other side. So then he is interviewing 3 people and he wants at least 1 gold medal winner. I find the exact probability there is at least 1 gold medal winner. So at least 1 gold medal winner is what? There are 3 people. So out of the 3 people, at least 1 gold medal winner means. And now there are 3 people. Okay, so there are 3. You are interviewing 3 people. So at least 1 gold medal winner means what? All 3 could be gold medal winners. So all the 3 people. At least one is, there should be a minimum of 1, right? At least 1 gold medal winner is out from the 3 people. All the 3 could be gold medal winners. Or you could even have 2 gold medal winners and 1 is not. Right? So, and the other one you could have it, there could be 1 gold medal while 2 are not gold medal winners. Can you see? Now these of course, you know, we can write a lot here, right? Like you can interchange and write A dash, you can interchange and write. This also you can interchange and write. Can you tell me now, this is actually a little bit of a trouble. Can you tell me the only part that you can't take here? He wants to have at least 1 gold medal winner. So the only part that you can't take here is what? If all 3 are not winners. If all 3 are not medal winners, then that part should not be taken, right? Because I want to have at least 1 medal winner. So then this is the only part that should not be. So then what the easiest thing? Take the part that we don't need and subtract it from 1. Can you all understand, children? So the only part, so the probability that we want, the probability, what is it? The probability there is at least 1 gold medal winner. Okay, so this is what you need to understand. Probability of 1 at least 1 gold winner is what? So you subtract from 1 the one that you don't need. You don't need everyone. You don't need the option where everyone doesn't have a gold medal. So everyone doesn't have a gold medal is what? Not having a gold medal from the medal winner category is 2/3, right? So that into what? There are 3 people, right? All 3 people into 2/3 into 2/3. So, or rather 2/3 cube. How much is it? Children, can you all understand? Can you all talk with me and let me know exactly what you think? Do you all understand the explanation here? Because it's important. How much? 19/27. So that explanation is important, that where you choose where you take it only from the medal pool category. So these are the probabilities. It's really important that you understand that. Okay, children? Is that okay? Okay, children? A group of students took some tests. A teacher is analyzing the average mark for each student. Each student obtained a different average mark. For these average marks, the lower quartile is 24, the median is 30, and the interquartile range is 10. The 3 lowest average marks are 8, 10, 15.5, and the 3 highest average marks are 45, 52.5, and 56. Okay, the teacher defines an outlier to be a value that is either more than 1.5 times IQ bar below the lower quartile or more than 1.5 times IQ bar above the upper quartile. Determine any outliers in this data. Okay, so that is quite simple, right? What do? You have to calculate your 2 boundaries. The 2 boundaries where if you exceed the upper boundary, you have outliers. If you are below the lower boundary, it's an outlier. So let's get the boundaries. I think to get the boundaries, we need to find what? Let's write the information. Lower quartile is given 24. Median Q2 is 30. Interquartile range is given. IQR is 10. So I think they haven't given you the Q3, right? Because you know you need Q3, right? You need Q3 to find the boundaries, the fences. So let's write interquartile range is Q3 minus Q1. Interquartile range is 10, Q3 value should be found. Q1 value is 24, which means Q3 is 24 comes as a positive 24 plus 10, positive 34, right? Q3 is positive 34. Do you agree? So let's get the upper fence and the lower fence, the upper boundary, or right, upper fence, anything. We are just finding the fence value that, if you exceed that, it becomes an outlier. So upper fence is above the upper quartile. So above the upper quartile is Q3 plus 1.5 times IQ1. Right? So the outlier is one more than 1.5 IQR above the upper quartile. So Q3 is 34 plus 1.5 times IQR is 10. Can I have the value here? The upper limit? 49. And then the lower limit, the lower fence or anything. Q1, right? So below the lower quartile. Q1 minus 1.5 times IQ1 because you have to go below the lower quartile. How much is it?
24 minus 15, that's 9, right?
So these are your upper boundaries and lower boundaries. Now, they in this data set, they haven't given you the full data set, right? They haven't given you the full data set, but they have given you the 3 lowest figures and the 3 highest figures. Like in the earlier past paper, I think they gave you the whole stem and leaf diagram question. The whole data set was available. But now in here, they only give you the first 3 and the last 3. Middle values are not given. So anyway, first 3, last 3 is more than enough. Why? Because normally the outliers are occurring not in the middle. Outliers are occurring at the corners. Okay, the extreme ends. So check the extreme ends. Do we have any value lesser than 9? So the values are, lowest values are 8, 10, 15. Yes. So there is a value lower than 9. So outliers, the first outlier is 8. And is there any value bigger than 49? Yes. 52.5 and 56. All of them are outliers. Agreed? Everyone is also, there are 3 outliers here. Children, do you understand? So on the grid below, draw a box plot for this data, indicating clearly any outliers. Once again, children, I'm reminding you, the upper limit, lower limits you found here, you don't mark them on your box plot. Okay, their only purpose is to identify outliers, the upper limit, lower limit. Okay, when you are drawing the box plot, you have to use the real data values. The real data values should be found. So the outliers, we mark it with a cross. So outlier value here is what? 8, right? So outlier is 8. It's a distortion in the screen. Okay. So 8. So 8 is over here, right? So 8 is the lower the value that is an outlier. So what is the next value who is not an outlier after 8? After 8, what's the next figure we have? The lowest value who is not an outlier is 10. Because 8, 10, 15.5 are 3 lowest values. Okay, so the lowest mark. So 10. So that means we start our whisker at 10. Okay, start the whisker at 10. Start the whisker at 10. Okay.
Yes.
Start the whisker at 10 and then
Q1 is 24.
Q1. Next one is you mark Q1 24. So mark Q1 24.
Q2 is 30.
Q2 is 30.
34 is Q3.
And Q3 is 34. And then mark the box Q1, Q2, Q3 makes the box, right?
Yes.
This is the whisker. And then the other side. First mark the 2 outliers. The outliers.
52.5 and 56.
Yeah, 2.5 and 56. So 52.5. 51, 52, 52.5 comes in the middle.
Yes.
52.5
And 56.
and 56.
And not outlier.
Okay, and then the biggest value who is not an outlier is
45.
45. Can you see? You don't use these figures. These are only to identify. So 56.5 are bigger than 49 outliers. The next biggest value who is not an outlier is 45. So the whisker starts at 45.
45.
So the whisker starts at 45. And then from there you continue it over here. And this is the box plot.
Yeah.
Can you see, children? That's the box plot. Okay, then let's move to the next part. Use the quartiles to describe the skewness of the data. Children, let's use this quartiles to describe the skewness, part C. So quartiles, remember Q2, we had to get using quartiles. We use the gap between the quartiles, right? Q2 minus Q1 value you should get, and Q3 minus Q2 distance you should get. How much is Q2 minus Q1? Q2 is 30, Q1 is 24, Q2 minus Q1 is 6. And Q3 is 34 minus Q2 is 30. This is 4. So which means what? Q2 minus Q1 gap is bigger than Q3 minus Q2. So these are theories in the book. So when you have Q2 minus Q1 is greater than Q3 minus Q2, is greater than what is this is a positive or negative skewness, children? Check the book. Yes, if it's not positive, it's negative. Okay, if it's not positive, it's negative. But so what's the answer? You all need to remember these theories actually. The skewness when Q3 is Q3 minus Q2 gap is smaller than Q2 minus Q1. You should remember. Okay, so I don't think anyone is remembering that negative skewness. So skewness measured, I think in the note we have done around 5 ways to measure the skewness by looking at the histograms, by looking at the mean median mode, by looking at the quartiles, even by looking at the box plot. You know, there are so many ways, and even by there's a formula, right? 3 times mean minus median over standard deviation. So many measures are there. There are 5 ways actually. So you need to remember it, okay? And so negative skewness, the reason is because this is the reason. Q2 minus Q1 is greater than Q3 minus Q2, therefore negative skewness. Okay. And let's move to the next one. 2 more students also took the test. Okay. So now what's happening in the earlier question? A group of students took the test. The teacher is analyzing the average mark for each student. Okay. So that was what was given. Now 2 more students, or 2 more extra students, right? Also took the test. The average marks which were both less than 45. Okay, so the average marks are both less than 45. So that means it comes inside the data set, right? I added to the data and the box plot redrawn. The median and the upper quartiles are the same. So they say the median and the upper quartile are the same, but the lower quartile is now 26. Redraw the box plot on the grid below. Okay, redraw the box plot on the grid below. Okay. So how does this change? Okay. So there are 2 more students also took the test, the average marks, which were both less than 45. Okay. Are added to the data and the box plot redrawn. Okay, so it's like this. Now you have your data set, right? Okay, let's say this is our entire data set. Okay, so this is the starting value. This value, let's say over here is Q1. Over here you have Q2. Over here you have Q3, right? This is the lowest value. This is the highest value. This is how you have the data is equally divided. Like each part equal divided means you have equal number here. Equal number of people here, equal number of people between Q1, Q2, equal number of people, like you equally divide. So now they are saying 2 more students are also taking the test. Okay, now let's say Q3 is how much? 34, right? Q2 is how much? 30. Q1, now this is the original data set. Q1 is 24, right? Can you all check this is okay, right? Yeah, right? So they are saying here the average marks are both less than 45, which means it's definitely part of your data set. Okay, and they say the median and the upper quartile are the same. The median and the upper quartile are the same. So think about this, children. So if the median and the upper quartile are to be the same, okay, now remember when you are putting a person here, this pool is changing, right? Now if there were like 3 people, like just for example, say there were 3 people down, if there were like 12 people here, you divide 3, 3, 3, 3 here, that's how we divide it. Just for an example, okay. So I'm just putting 3 crosses. There are 3 people, 3 people, 3 people. That's how you divide the marks. Okay, so now the median and you are going to put 2 more people into this group. The median and the upper quartile are the same. How can the median and the upper quartile be the same when 2 people are put here? How can it be the same? I think before we go to that part, Sharon, we need to do part D. Sorry, I missed part D, right? Let me explain that part properly again. Okay, so before we go to that part, let's redraw the box plot. So what's the box plot? The box plot, they say the upper quartile and median are the same, but the lower quartile is changing. So when the lower quartile is changing, what happens? Your interquartile range will differ, right? When your interquartile change is changing, what happens? Can you all just draw like that? You have to now again check what? The upper limits and the lower limits and check whether the outliers. You have to check for the outliers again. Okay, that's why you have how many marks here? That's why you have 3 marks. Shall we do that part first? I think I was going for part D, part E. Okay, so let's get the interquartile range, the new interquartile range Q3 minus Q1. The Q3 value is the same, they say. Q3 value is the same, which is how much? Q3 value was
34 minus 24.
yeah, no, Q1, the new Q1 value? The
26.
26.
26. So how much
Yeah,
is
then
26?
8.
8, right?
Can you all get the upper limit and the lower limit again? Upper limit is Q3 plus 1.5 times IQR, right? Get the upper limit and the lower limit again. So Q3 is 34 plus 1.5 times interquartile range is 8. Can I have the upper limit? 46. What is
46.
the limit? Q1 minus 1.5 times IQR. Q1 is 26 minus 1.5 times 8. How much is it?
14.
14. Okay, so now the 3 lowest values and the 3 highest values are given to us. So consider the upper limit, lower limit, 46 and 14. So do we have any new outliers? Children, do we have any new outliers?
10 is outlier.
Let me take this down. Because I have to keep moving the page. So I took the limit, I took the figures down here. Children, look. So what are the values that are exceeding or it's below? So the 3 lowest average marks are 8, 10, 15. So what are the outliers now? Any value, are there values lower than 14 here?
8 and 10.
Yes. 8 and 10. So there are 2 outliers now. Can you see it has changed? Previously we only had 8. Now we have both 8 and 10. Okay. And what about the upper limit? The upper limit is 46. So who is bigger than 46?
52.5 and 50.
56. Okay. So 45 is escaped. So the for 52.5 and 56. Are you okay with it? So let's draw the box plot now. So outliers are at 8 and 10. Outliers are at 8 and 10. Then the box plot starts from what? 8, 10. The next figure is the whisker should start from where? 15.5. Are you with me?
15.5.
Biggest value
Yes.
that's not an outlier. So 15.5, this is 10, 15 and 16. And starting between 15 and 16. Okay, 15.5. I'm correct, right? This is 15 and 16, 15.5. Then Q1 is 26, right? They say the upper quartile is 26. Okay, children. And then median is same. Median has not changed. Median is 30, right? Am I correct? No, median was how much? 30, yeah. Median doesn't change and upper quartile is 34. That also doesn't change. Okay, so then you can complete the box here. And then the other side, children. So what is the biggest value that is not an outlier? So you saw 52.5, 56 are both outliers. So 45, right? 45 is the biggest value. Who is
Got that right.
So 45. The whisker should go until 45. And then mark the two outliers. Who are they? 52.5,
And 56.
51, 52, 52.5 and 56. Okay. Okay. So this is the box plot. So this is the new box plot with the changed mean. Sorry, with the changed lower quartile. So the lower quartile changed. So this is the new box plot. Okay, so the next part E is just 2 marks, but it requires some high level of thinking. Okay, shall we move to part E? Box plot is okay. Box plot is quite easy. The only thing in the thing that you need to remember to do in the box plot is to calculate the new limits. The upper fence, lower fence should be newly calculated because Q1 changes, IQR changes. So definitely the upper limit, lower limits will change. So then you have to get the new outliers. That is the only thing that you need to remember to do in part D. Okay. So part E, now they are asking to give ranges of values within which each of these students' average marks must lie. So coming back to the sum children, what did we do? So I was partly explaining this in the earlier one. They are saying two more students also took this test. So earlier we had a group of students and we had a means, median, the Q1, Q2, Q3. This was calculated for the earlier one. Okay, so yeah, and then what they are doing is now they are going to add 2 more people into this group. Okay, so they are asking when you add it to this group, they are saying the median and upper quartile doesn't change. These two guys don't change. There's no change, but this one will increase. Q1 will increase to become 26. So they are asking you give ranges of values within which each of the students' average marks must lie. So in what range will the marks lie? Okay, so it's like this, children. It's like this. Basically, all you need to do is to remember the simple theory of the median. Now, imagine, I mean, normally you keep your data in these kinds of data, you always keep in ascending order, right? So when you keep a data set in ascending order, okay, so for example, let me give a simple example. So say I have here 10, 20, 30, 40, 50. So if I take a data set like this, children, just to demonstrate to you an example, what's the median? Median is the middle value, right? Who is the middle? It's in order. The middle value, median is 30. This is the median. Okay, so now what I'm going to do is I'm going to introduce, I want you all to think and tell me, introduce 2 people here so that the median doesn't change. Can you all introduce me 2 people so that the median doesn't change? So if I'm introducing 2 people here, for the and in such a way so that the median doesn't change, how should I introduce it? Children, do you see the theory here? The theory here is how to introduce people into your data set without changing the person, the original person here. So I think you can see now median is always the person when you arrange your data in ascending order, the person who is in the middle. Okay, so for example, I mean, what can we do here, Buddha? So to introduce 2 people here in such a way so that the median doesn't change, all you have to do is what? One person should be lower than 30, the other person should be higher than 30. Can you understand? Even 30 is also fine, right? 30 or higher than 30 is also fine. So one person lower than 30. So example, if I introduce 25 or say I introduce 5, it doesn't matter what it is. If I introduce 11, the size doesn't matter. Does the interval matter? Does the interval matter? Whether it's interval of 1, whether it's interval of 2, it doesn't matter. It's the position that matters. When you are considering the median, children, the interval, the gap, those things are not mattering at all. Okay, so the only thing that matters is the position. So whether the position changes. So if I introduce one person here, I can introduce another person over here even. 55. Does it matter? If whether that is not over here, that is not in the middle, no, it doesn't matter. All I need is, yeah, the median is now you have 3 people behind, 3 people front. That's all. Still, this is the median. Do you guys get this theory? Can everyone understand? Please ask me questions about this theory. This is the important one. So I introduced 2 people here. It doesn't matter where it is introduced, as long as one person falls behind and one person falls in front. Even if it's an outlier, it's fine. Okay, even if it's very close, it's fine. Do you get it? Children, can you all please give me some kind of a feedback here, because this is an important theory, and that is the theory I'm going to use here to explain why certain people are changing and why certain people are not changing. Are you guys with me? Yes, Melinda, is this okay?
Yes, teacher.
Okay, so what happens if I introduce both these people? Say I introduce 2 people who are both bigger than 30. Say I'm introducing 35 and I'm introducing 46 or something. Now what happens? If I introduce these 2 people like this,
Median will increase.
the median will increase. Can you all see? Because now both the people are here, the middle value actually comes where? This guy to this guy cancels. This guy to this guy cancels. This guy to this guy cancels. So now the median is 35. The median has increased. Do you see? I'm just giving you an example here to understand what's happening here. Okay. So median has increased. So how does the median increase? If both the figures that you have put is above the current median, median will increase. Do you guys understand it? If both the figures that you put is greater than your current median, your median will increase because the position shifts. The position simply shifts. So what if both the values we introduce is going behind the median?
Median will decrease.
Median will decrease, because if I put both the values here, the position will shift behind. Will shift backward. So median will decrease. Can you all understand the theory here now? So this is the theory, children. This is the theory that we use in here. Okay, so I have taken here the data set. So I have just put some process here to tell you that the data is evenly divided. The values come in the gaps of the values doesn't matter. The data is written in ascending order, and you count, like, you know, exact equal amounts of people are there in each quarter. Right, equal amount of people. If there are 10 people here, there will be 10 here, there will be 10 here, there will be 10 here. If there are 100 here, then 100 here, 100 here, 100 here. That's it. Equal amounts of people are there in each quarter. So I just put 3 crosses as an example. So now the thing is, they are saying when you are introducing 2 new people, and when you're introducing the 2 new people, what's happening? The median doesn't change. So if the median doesn't change, children, what does it tell you? The 2 values that you are introducing should be what? If the median doesn't change, it should be on either side of the median. Do you agree? Do you agree? Median does not change when you increase. Median does not change, which means what? The new values are on either side of median. Do you agree? Okay, can you all understand? Talk with me, will you? Do you get what I'm talking about? The 2 values you introduce here are going to be on either side. Okay? And then what about the Q3? Does Q3 change? Q3 is also there. No, Q3 also doesn't change, right? Where is it? The upper quartile doesn't change. So Q3 does not change. Which means what? The 2 values will fall. What were they? The 2 values fall either side of Q3. Can you all understand, children? The 2 values you put will be on either side of Q3. One will be bigger than Q3. One should be lesser than Q3. And what's the other thing they say? The other thing they say is what? The lower quartile is 26. So lower quartile has increased or decreased?
Increased.
Increased. Q3 has increased. So if Q3 has increased, now I showed you the increasing theory here by an example. If the value increases, that means both values have fallen what? Both values are bigger than Q, I mean the current Q1, or is it both bigger than Q3? Q1.
Both bigger than 2.
Sorry, Q1. I'm sorry, this should be Q1. Huh? So Q1 has increased. So if Q1 is increasing, children, I showed you here the increasing there. If your current person is increasing, that means both the figures you put should be in front of it. In front of it. Can you all understand? So then you understand here, both figures are higher than Q1. Can you all understand, children? Please talk to me and let me know whether you get this. This theory is, you need to understand the theory here. So now what do we do here today? So now think of the range. So so definitely you understand both values are falling above Q1. So that means so what are the number ranges here? The smallest number we have here is, okay, so this is 20. Okay, so how are the values falling? So definitely, both numbers are falling bigger than Q1. Okay, both values are bigger than Q1. So then, children, and one value should be smaller than median, which means definitely one value, one cross should be between Q1 and Q2. One cross should definitely be between Q1 and Q2. Agreed? Okay, so you can see one value right here. So one value. They are asking the ranges of values. So one value between what is Q1 and Q2? Between, you can say 26 and you can give the new value 26 and 30, Q1 and Q2. One value is definitely between these two. Okay, so what about the other value, children? Now the other value, definitely has to be bigger than Q2. Listen, so I introduced one value here. Now one value is here. Okay, look at this. So one value is here. So now the other value, to keep median in balance, the other value should be introduced to the other side. So now in the other side, there are two places to put. Either you are going to put in between Q2, Q3, or you are going to put in between Q3 and the highest value. Okay, either you are going to put between Q3 and the highest value. So how are we going to put it, children? So if you put it over here, Q3 will, the median will be balanced. If you put the new person over here, the median will be balanced. But what about Q3? Look, both the people that you are putting is behind Q3. So then if both the people you are putting is behind Q3 will decrease, right? Because if both are behind, so they say Q3 should not change. Then what's the theory? You should put the cross on the other side.
Above Q3.
Above Q3. So when you put the cross above Q3, so you can see now the value, when you take Q3, there's a value in front of Q3, behind Q3. So Q3 is balanced. If you take the median, one is behind median, one is above median. Median is also balanced. Median doesn't change. And Q1, both values are bigger than Q1. So Q1 increases. So the other value, one value between how much? 34 and 34. Okay, so this is the range of X values. So this is how your data values should fall, children. So that is, I hope you guys understood that. Okay, that was quite an explanation. I really hope you all got that.